Okay, great. Thanks. Appreciate that, man. We got two more participants here. Start off with Manny. You may unmute yourself. You're just looking for a quick introduction.
Hello. Yeah, right. Can anybody hear me? Well,
Yeah,
yeah, I did a little bit of database, Oracle for about like a year. Then I did Linux administration, and I've also taken the time out to look into AWS, and I'm pretty interested in it. So I'm trying to, start learning more about it, AWS. But currently, I do help desk.
all right, great. So you're more into database, Oracle specifically, right?
Yes, I did Oracle database for about a year. Then, move on to Linux administration, and now I'm trying to do the AWS, get it out of the way.
Great, great. Sounds good. Sounds good. Thanks, Manny.
No
And then we
problem.
got your friend Ibo.
Hi. Um, so I did a little bit Linux, and I'm trying to learn some AWS to add to it. And Manny was the one who introduced me to
Right,
this.
right.
Yeah.
Great, yeah. Sure. Welcome to the session.
All
I
right.
think
Thanks.
both of you, Manny and yourself, you're in Linux and database administration. Ramesh is more into development. Kieran is also into development. We got a heterogeneous mixed environment here. We're gonna keep it slow. Um, because we will be talking about several services that developers will need, web developers will need, front-end developers and infrastructure people as well, database engineers. And the AWS is not just for one particular kind of IT community; it's for everybody. So um, that's where we gotta start ensuring that our backbone or the foundations of the infrastructure must be pretty strong here. And first couple of days we'll be doing just that. All right, to start off with my introduction, I've been in IT since 2003. That's when I graduated. I graduated in electronics and instrumentation engineering, and then also did my master's in computer science from the University of Windsor, Canada. I did my post-graduation diploma in cyber laws from a local university here in Hyderabad. I am from Hyderabad, India. That's where I hail from. Um, as far as certifications is concerned, the first certification that I did in my career about 10 years ago was an Active Directory. That's my bread and butter. Identity and access management is that I've lived on most of my career. Could be Oracle Identity and Access Management, Active Directory, Federation Services, Single Sign-On. That's what I've been doing for a very long time. But from past 5 years, this advent of cloud computing, our company where I used to work, my last company was Qualcomm, which is a leading chipset manufacturer, designing company. That's where I used to work. I was working on identity and access management, plus also setting up disaster recovery systems in the cloud. So business continuity planning, setting up disaster recovery system for an estate of 270 domain controllers that we had worldwide, geographical footprint. Um, so we initially started setting up DR systems in Azure, Microsoft Azure, in about 2000, like 5 years ago, whenever that was, 2012 or something. So we set up like 16 domain controllers across different data centers in Microsoft data centers. And where Microsoft initially started cloud services, they were not really that great. So we always had issues and bugs. So we moved on to another cloud service called Amazon Web Services. Yeah, it was was at its inception stage, very initial stages. Back then, there was no talking about the certifications that I had to do in last couple of years. Um, so I started with my Microsoft Azure certification in 2012. That was 7533. It is called as Implementing Azure Solutions. I also did 7534, which is Architecting Azure. Then, as we moved on to AWS, we had our infrastructure in AWS, core services that were offered in AWS. I got myself hands-on on various AWS service offerings in like 4.5 years ago, and I also had to get myself certified just to prove to the clients, of course. So that was on Solutions Architect Associate as well as on SysOps Associate. A few weeks ago, I also got myself certified on Google Cloud Platform. So I'm also a GCP architect. Security is one of my passionate areas, so I try to learn a lot on security and try to get myself certified on as many security platforms as possible. So I did my AWS specialization on networking security certification a few months ago. Security Plus is from an organization called CompTIA, Certified Network Defender, also from EC Council. Um, I'm looking forward to get myself certified on OSCP in about next 6 months. So that means like 6 to 8 months of preparation. Includes knowledge of um, Python and certain web scripting levels, etc. So that's quite an intensive exam. So I'm looking forward to get myself certified on OSCP um, in next 8 months by August. So that's in pipeline. So that was about me. So I'm more from the infrastructure side, not from the development. Infrastructure, specifically Active Directory, Microsoft Exchange, Office 365. So those are my key areas. And in this session, we'll be talking about what Amazon Web Services Solutions Architect Associates demands for, the knowledge that is required for you to write the examination. At the same time, as and when there's an opportunity, I'll be sharing experiences or the situations that I've dealt with. So that is you will get certain exposure to what has happened in real time while I was working on issues. I'll just fix this thing. View. Okay. Okay, let's go get started. Well, the picture that you see over there on the left-hand side is small pictorial representation of a data center. That's how the data centers look like. So if somebody had to draw a three-dimensional picture of a data center, that's how it is. You got racks, switches, firewalls. You got hot aisle, cold aisle, network operation center, signals and systems, and there's a whole lot of investment that goes into building up a data center. It's quite a lot of investment, right? If you want to set up. And we're just talking about one data center. For a company that has geographical footprint that's everywhere, they need as many sites or as many data centers, as many offices that they have, right? So I remember when I was working for a company called Kantar, we had almost 300 sites. That means setting up 300 data centers, big or small, right? So hub sites or the main sites like New York, Lyle, UK, they were like massive, whereas other ones like small, which were in Turkey, Ankara, certain ones in South Africa, they were small, but regardless of the size, you will need certain amount of investment. And today, in this world where technology has been adopted at such a rapid pace, we cannot wait for all that time to build a data center. Although you may have quite a lot of money, there might be a lot of funding, so you have a lot of kind of capital expenditure sitting sitting in your pocket or your company's budget. Even though you have quite a lot of funding, you do not have time because setting up a system like that takes a lot of time. I remember when we were moving our data centers from one region to another region in Qualcomm, we were actually shutting down one of them and creating another one about 500 miles ago. So 500 miles away. They were like um, about 8 months. It took 8 months to build the entire infrastructure in a different site. But if you think about today's infrastructure, if you think about in today's world, we do not have so much time because we are living in the startup world. The startups really do not have time, right? Even though they may have funding, So the capital expenditure, yeah, that's one thing. Organizations may or may not have capital expenditure. Second one is time to market. We really want to cut down on the time to build such infrastructure, time to time to deliver the product to the customers. And third one is the operational expenditure. The first one, which we are talking about, is a capital expenditure. Any amount of or any investment that initially goes into building something is called as capital expenditure. Operational expenditure is recurring expenses. Month on month, you pay the heating, ventilation, air conditioning costs, electricity costs, maintenance, manpower costs. So these are certain factors that attract infrastructure towards moving to one of the cloud providers. So three primary things. One is capital expenditure, second, operational expenditure, third, time to market, which has led to exponential rise in the adoption of cloud. So we are talking about two primary vendors in the cloud: Microsoft Azure, Amazon Web Services. There's another one, Google Cloud. GCP is also picking up nowadays. And if you heard of this game called as Pokemon Go, yeah. So that's there in Google Cloud. Amazon Web Services, well, it has Airbnb. That's a platform to book your hotels, Airbnb, and also for any real estate property owners to post their property on the website so that people can get attracted and start booking up their rooms for vacation or for whatever purpose. That's there in Amazon. Uber is on Amazon. And small and large and medium business companies, they're all moving towards AWS, Azure, or now Google as well. In order to do the labs for Amazon Web Services, you need to have an account created, right? So make sure that you have an account created. I'm going to tell you how to create an account. Understand. That's what we're going to do in the next 1 hour. We'll see how the cloud computing has evolved over a period of time. Talk about different cloud models like SaaS, PaaS, and IaaS. What is your responsibility in managing the infrastructure? Because in traditional infrastructure, when you had data center within your four walls of your office, end to end, responsibility always lied with you. In the cloud, is it different? As we'll talk about it. How about public, private, and hybrid? These are called as deployment models, differences between them. What are the 5 key characteristics of cloud computing? So when somebody says cloud computing, Amazon, Azure, or Google, or whatever, um, what are the characteristics that one is looking at? So maybe you want to make your own cloud, right? What are the characteristics that you're looking at? And we'll also take a look at AWS console. I'll tell you how to create your account so that you can do the labs moving forward from tomorrow, right? But before we dive into that, let's try to understand the definition of cloud computing. There are so many providers in the cloud today. You have Amazon, Google, there's Rackspace, DigitalOcean, Microsoft Azure, um, CSC Cloud, Oracle Cloud, VMware Cloud, China Top Gun, Alibaba. He came up with his own cloud called Alibaba Cloud, right? So there's so many of these cloud providers. When there are so many providers, there must be some kind of a standard as well. Just like if you think about networks, we got devices of all kinds. We got laptops. My laptop is HP. Your laptop may be from Lenovo, or somebody may be using a Dell, or our friend may be using a Mac. All of us get connected to the same wireless router, right? So regardless of what your manufacturer is or who your manufacturer is, the device can still transmit and receive signals from the same wireless device. That is because manufacturers, when they manufacture the network card, wireless or wired, they ensure that certain protocols are followed, specifically as designed by the standard called ISO OSI, the OSI 7 layers. You might have heard of those 7 layers of OSI, right from the physical to application. That's primarily possible because there are standards. Otherwise, HP laptop would say, hey, you can connect only to HP routers. Whereas a Dell laptop will say you can connect to only Dell routers. So that will be a big issue for people like you and me, right? As you come to your home, you have your Netgear router. When you go to your office, you have a different kind of router. So you'll have multiple network cards. You'll need multiple network cards in that case. That will be such a user inconvenience, right? And that's the whole purpose of standard. And standards are used to standardize the behavior of technology. Similarly, it was just an analogy or a comparison. When we talk about cloud computing, we got so many vendors here, and it's important to standardize. So people like you and me, we are technology enthusiasts. We are very much passionate about cloud, and moving forward in the years down the line, we start to build our own cloud. Is there a definition that we should follow? And who gave this definition? Well, on the screen, you see the definition as given by NIST. NIST is National Institutes of Standards and Technology. This is a governing body sitting in the United States, not governed by the United States. It's about 183-year-old organization that gives units of measurements and standards for various technologies. The definition as given by them is there on the first bullet point. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Let's try to break it down and try to understand that in simpler terms. What is cloud computing? Now, if you are able to provision infrastructure, when you say provisioning, it is creating. Deprovisioning is deleting or getting rid of it. So when you are able to provision and provision resources whenever you want it, from wherever you want to build, with minimal interaction from cloud provider, is nothing but cloud computing. Let's try to break it down even further. So you have an idea in the middle of the night, and you want to build a small program. To build that program, you need heavy duty infrastructure. Like let's say you need a CPU with 64 GB of RAM, 2 or maybe multiple CPUs, couple of terabytes of hard disk, SSD, and that will take, again, quite a lot of money and investment, right? That's one. Second is, you don't want your idea to die. You want that to be implemented right then and there. But then it's middle of the night. You cannot just walk into any store and start buying it right from there, right? Because the stores will not be open. You have to wait for the clock to strike 9 the next day and then drive in there, build your PC, and then get in. So your idea basically takes a while to get implemented, right? So we don't want the idea to wait at all. If you have an idea, all you've got to do is log into the cloud systems, any cloud system, AWS, Azure, Google, anything, and then build whatever you want, any kind of resource like servers, racks, switches, firewalls, storage, database, email solutions, CDN, content delivery networks, just anything. And that should be rapidly provisioned whenever you want it, not when the cloud provider wants it. And we do not want the cloud provider to put their fingers in it. That means I do not want to call my cloud provider like Amazon or Microsoft and say, hey, can you build a system for me with 64 GB of RAM with 4 CPUs and 2 terabytes of hard disk, and make sure that port number 80 is open, and yeah, make sure that you install database in it and allow 1433 port number. So no, we're not getting in there at all. You build it yourself. You do not call the cloud provider, right? All you got to do is go ahead and start building your systems right from scratch, and you have the platform. You have the platform to build it, right? That's what the definition of cloud computing is. Do you have any questions for me so far?
No.
Not from my side, Anand.
No.
Okay. Okay, thank you. Now, if you don't have any question, I have a question. Okay. Having, yeah. Okay, so now that we know the definition of cloud computing, do you think cloud computing is new? Is it really new? Or has it been, or is it a gift given by Amazon and Microsoft, and then say, hey, you know, take these cloud services and you save a lot of money for your company. You save not just money but also time. Is that what it is? Is that a gift given by these large organizations? Or has it been there ever since the evolution of information technology, IT, several years ago, like decades ago? Department of defense, the DoD in the United States had their own intranet services to transfer and transmit the critical, crucial, personal identifiable information within themselves. That was top secretive, but then slowly they started spreading their wings to various places, and they realized that, yeah, TCP is something that everybody has a right to use. It's a birthright that everybody must use TCP as a forms to communicate to the rest of the world. So, but then DoD cannot do that because they are not commercial entities, right? They are there for a specific reason. But they call it the commercial entities, and Bell Telecom was the first one, and this they said that, Bell, you go ahead and take the lead and start distributing the TCP stack to the world, and let people use internet and not just intranet. So people around the world should be able to communicate with them with each other, and let us gift it to the world, right? So Bell Telecom had a larger responsibility of distributing and then setting up the cabling around the world, which they cannot, of course, do it alone. So they had to partner with several entities around the world. So ISPs then came into picture, and then people like you and me are able to use internet and use, medium like this, go to a meeting to talk, and we are using TCP as an underlying layer to transmit signals in the form of data and voice, right? Now, back to the question, is cloud computing new, or has it been there ever since the evolution of internet? You can put your answers in the chat, or maybe unmute yourself and answer. Yep,
I think cloud, yeah, I think cloud computing has been around for a while. It's just like right now they just move it to a whole different,
right.
different. This made it's pretty much they just move it to a whole different standard or different way of doing things. Where now you have all the service and everything sitting in one place and you have access to it instead of just like when you have your laptops and your computer at home. By this time around, they just have everything just sitting somewhere where you can have access to. So I think it's just been around. It's just they just improved upon the way we just use the computers or access data.
Right. Right. Agreed. Yeah, absolutely. I think Manny is right here. But if you think about Gmail or email services, when was the first email address that you created? Or right in school, maybe college, maybe when you got graduated, but you were accessing your emails from that 15-inch CRT screen. I remember, like 16 or 17 years ago, whenever I created my email address. So, well, we never had to set up email exchange systems at our home. All you needed was an internet with decent bandwidth and then a browser. That's all, right? You need a browser, you connect to it, and then you have your email systems right in place. You can send and receive emails. Chat messenger tools are available. You can chat with whomever you want, right? But then for that, you do not have to set up a chat server at your home. What you needed is a software that can connect to the chat server, which you do not own, which you don't even know where that is. We don't want to know who the provider is, right? So I think that exactly fits into this definition, where we say that, hey, you are able to talk to anybody at any point in time with minimal effort and minimal communication from the service provider. We never have to contact Google to create our email address. We will never contact Google to delete our email address. We will never contact Google to manage our emails, to delete and put them in respective folders and labels. You can create a Gmail account whenever you want it, from wherever you want. You can be sitting in an airport, in a subway, in a metro, in a railway station, at your home, in your office, from a cab, wherever. All you need is a device that has internet, right? That's exactly what cloud computing is. So basically, the entire world today, whoever is using smartphones, is using some other form of cloud computing. There are different models in the cloud, which we'll talk about, but we have come a long way in the last couple of decades. Initially, when you had to set up a data center, oh, that was time consuming. We started with traditional data centers. That means um, if you want to set up a web server, you buy one server. You want to set up a database server, you buy another server. You want to set up a LDAP server, a middleware server, um, an Exchange server, a Linux server for application purposes. So overall, let's say to build a company, you need 10 servers or 10 applications. You have to buy 10 servers. I'm talking about like several years ago when virtualization was a dream, not a reality. So if you have to buy 10 servers, let's say each server is costing about $10,000, 10 servers will cost $100,000, and that's massive capital. $100,000 20 years ago was massive, heavy investment. But then organizations had to do that. They had no option because computing was expensive. In about 2005, 6, 7, till 2010, virtualization was a buzzword. Organizations like VMware and Hyper-V steered their way up to the virtualization layer, where organizations like VMware and Hyper-V created their own products, like VMware ESX, Hyper-V, Microsoft Hyper-V, Zen Server, Oracle VirtualBox, VMware Workstation. These are virtualization softwares. So instead of buying 10 different servers, you buy just one single humongous piece of hardware and then install something called as a hypervisor layer. I'll explain that with a small picture here. Right there. So let's say that's your hardware, right? I hope you can see what I'm drawing here. And hardware has like 64 cores, 256 GB of RAM, and then it also has 2 TB of hard disk. But then in the real world, you do not connect. That's your storage. On the right side, it is your storage. In production world, you do not use the inbuilt storage systems. You connect your hardware. You connect your hardware to the storage area network. You connect like that. Now, instead of installing operating system on this hardware, what you're doing is installing hypervisor layer right there. That's your hypervisor layer. This hypervisor layer can be from any provider like VMware, Microsoft Hyper-V, or Citrix, or whoever, or Oracle. And once you have the hypervisor ready, you will then have virtual machine 1, web server, second virtual machine, database server, third virtual machine, LDAP server, fourth one, application, middleware, and you can just go on. So when this VM1, which is a web server, it needs resources, it communicates with the hypervisor. The hypervisor then communicates with the hardware. The hardware then gives it back to hypervisor. Hypervisor gives it back to the web server. So hypervisor is sitting in between your hardware and the virtual machines. This kind of virtualization is called as type 1. Type 1. Type 1 virtualization. There's another one called type 2. Type 2 virtualization is where your hypervisor will be there, and there will be another layer right here called as the operating system. Operating system layer. I'm sure you might have used this software called VMware Workstation or Citrix Zen Server, right? or maybe Oracle VirtualBox. These are virtualization softwares for your sandbox environments. So what do you have there? You have the hardware, which is your laptop. On top of it, you got your Windows 10 or Windows 7, and then the hypervisor layer, which is created by VMware Workstation, and then you create virtual machines. These are called as Type 2 virtualization. That's where we were. And then we moved on to private cloud environments. Now, every technology has a problem statement. We just do not create products for the sake of it. There is a problem statement. The problem statement in traditional data center was heavy investment and time. A lot of things were saved when we moved on to the virtualization world. We saved a lot of time, yeah, we saved a lot of capital expenditure, but then buying a system like this takes a lot of money. This kind of hardware takes a lot of money, then plus you need this SAN hardware. SAN is called Storage Area Network, which is provisioned by companies like EMC, NetApp, and then Hitachi. These are the providers for storage, and these are not cheap. SAN is very expensive. So even in the virtualization world, you had to have quite a lot of expenditure out there. There's another problem here. The problem statement is, let's say if a developer has to build a front end and a back end system, a front end with a web server and a back end with a database, he will do that pretty quickly on his sandbox environment. And then to put them in production, he needs infrastructure like that. But the developer does not have access to this infrastructure because in enterprises there are separate teams managing it. Developer then has to contact the infrastructure team with the help of ticketing tools like ServiceNow, Remedy, Pi5, so many of them. The developer creates a ticket for the infrastructure team. He cannot create a service, he cannot create a priority 1 because it's not business down, nothing critical. He has to settle down somewhere between priority 3 and priority 4. Infrastructure team is really busy doing a lot of things, building infrastructure not just for you, but several other customers. And also, they have to do upgrades and patches and downtime and so many things the infrastructure team is doing. So your ticket may sometimes be sidelined. What is being affected here is time to market, right? So when time to market gets affected, then reputation also gets affected. Because let's say I'm your customer, you say that I can build the code in 2 days. Well, you build the code, but it's not in production yet. It's not in production yet because infrastructure team is busy doing their activities, right? So hence, I as a customer will think that, hey, this guy said 2 days, but then it's taking longer, so hence reputation gets affected. The time to market is the key. This is a problem statement. And this problem was sorted out or solved in private clouds. Private cloud is as good as virtualization. This is the exact same thing. This box, the second box, and the third box are the exact same thing. The difference is that the developer now has access to the infrastructure. The infrastructure is still there within your 4 walls, but the definition of cloud then kicks in. It means that the developer will be able to create the resources like a front end and a back end whenever he wants it, from wherever he wants it, with minimal intervention from the provider. Who's the provider? The infrastructure team. So private cloud is where the infrastructure is within the 4 walls, but then the people who need access will have access, and all they have to do is log into the portal. They have a self-service provision portal, so they'll go to http:// the IP address of your system, of your public cloud system, or the name of your public cloud system, and then type your user ID and password. Then create your systems, right? So there is no dependency on the infrastructure team. That is private cloud. A public cloud is where the infrastructure is not in your infrastructure. 100% of your infrastructure is out there with some provider. Organizations like Netflix, Uber, Airbnb, Quora, they have their 100% infrastructure in the cloud. All the organizations have is internet and devices. From there, they can connect to the provider. That's all, or provide or to their infrastructure services. A combination of public and private is hybrid. A combination of public and private is hybrid. So a part of your infrastructure is there in your public environment. A part of your infrastructure is there in your private infrastructure. A use case of this could be, let's say, since you're most of your database guys here, I say, Ramesh and Ibo and Manny have been handling my database for quite a long time in your private infrastructure, and I say that, build certain infrastructure for me, but then make sure that you keep the database in your premise, in your four walls. Do not keep it in the cloud at all, because it has my personally identifiable information, PII information, and I don't want to expose it to the cloud, because you have been doing a great job in protecting my database for the years, right? But in the front end, the web front end can be there in the public cloud. So you will go ahead and design a system where the front end, the web tier will be there in the public cloud. And when the web tier has to communicate with the database, it communicates privately with your data center, because the database is hosted in your data center. So these are differences between public, private, and hybrid infrastructure, and where we were all these days and where we are, where we are going. Do you have any questions on cloud models?
No.
Okay, cool, thank you. All right, so let's talk about SaaS, PaaS, and IaaS. I wanted to ask this question quickly. This session was scheduled for 1 hour. I'm okay extending. I'm okay to move on, because I'm sure this will take another hour to complete the rest of the slides. We're just 5 slides done. We have 20 more slides. So I wanted to ask, can we move on, or should we move it to the next day, which is tomorrow? Or are you okay with me continuing this one? Because you might have committed it somewhere that, hey, I'm going to be there in 1 hour, have a session for 1 hour, and I'll be back. I don't want to eat up your time. I'm okay continuing, unless you have any objections.
I will be here for the next 30 minutes, then I'll just leave. So it's okay if you continue.
Okay. Thanks, Ivo. Kiran, Manny, Ramesh?
Yeah, I'll be on till like probably like 10.
So that's like 30 minutes, I guess.
Okay. So you're okay for next 30 minutes, right?
Yes.
Yes.
Okay. Great. Ramesh, you okay as well? Kiran? Okay, thank you. Awesome. Yeah, let's keep moving then. All right, so let's talk about cloud models, which is SaaS, PaaS, and IaaS. Let's try to understand them. What is software as a service? The software as a service is where software is provisioned to you over the web browser. Let's try to understand with examples instead of just going through the definition. Gmail. Every time you want to access your email services through Yahoo or Gmail or Hotmail, you launch your browser and then access the services. You do not ever have to install anything on your computer. Today, you can even chat within the browser. You can even talk to somebody using Hangouts. That means communication in the form of email, voice, and data can be done right from the browser. That is nothing but software as a service. Office 365 is another best example. When you have to access your corporate emails, all you have to do is open your browser and then type in whatever is the link for your Office 365, and then type your user ID password, you get your emails, right? Office 365 is an example. Zoho, the entire suite of Google Apps, Google Talk, Mail, Chat, all that is software as a service. Salesforce is a CRM solution. You do not have to install any application there, right? Software as a service. Next one is platform as a service. Platform as a service is a big boon, a big advantage for the developers or even the database guys, or the people who wanted a strong backend mechanism. The database have been the backbone of any infrastructure, backbone of the front end and the back end, the web tiers, specifically the front end web applications. So you want to build a website, well, you go ahead and build a website, but the back end must be a database, and you want that database to be pretty strong. Then you will consider platform as service, because by doing so, you will have the infrastructure, which is the platform, provisioned pretty quickly. So here, you do not have to worry about the server that is running the infrastructure. Think about SQL Server. So when you want to deploy Microsoft SQL Server, what do you need? You need hardware, then you install operating system on it, then you go for server hardening, then you install SQL Server or maybe Oracle Server or MySQL, whatever, and then you go for hardening of SQL for security purposes. And the whole procedure takes a lot of time. In platform as service, all you do is select a database, that's all, and say next, finish. Your database is created. What kind of server is there in the back end? What is the operating system on that server is something that we don't have to worry. We don't even have to patch and manage and update any vulnerabilities found in the system, right? You can just go ahead and run that systems directly. That is nothing but platform as service. Your application can directly connect to the database with an endpoint that is given by the PaaS provider. I don't know where it went. Okay. All right, so that was platform as a service. The next one is infrastructure as a service, which is our favorite. So when you want to build servers, racks, switches, firewalls, load balancers, autoscalers, all that is infrastructure as a service, and that's provided by leading cloud providers. Pizza as a service. Never heard of it, right? This slide or this chapter over here tells us the responsibility. What is your responsibility in each of those segments? In infrastructure as a service, platform as a service, and software as a service. Well, since the infrastructure is hosted at the cloud provider's place, what is your responsibility and what is the cloud provider's responsibility is what this Pizza as a service slide explains us. It's just an analogy. Nothing in real like that exists, right? So if you look at traditional on-premise infrastructure, building infrastructure in your office or building data center for your office within your own premise is as good as making food at your home. That means you're responsible end to end for everything. You're responsible for cheese, toppings, tomato sauce. You got to make all those things end to end. And this will be time consuming as well. Time to market. You have to pay more, the more expenses. On the other side, you say that, hey, I don't have so much time. Let me go out to the market. I'll go to the nearest mart, maybe 7-Eleven or something. You go pick up certain things like cheese, toppings, tomato sauce, and pizza dough. That is difficult to make at home, difficult to prepare at home. You bring it home and then assemble them all together, put them in the oven, wait for a couple of minutes, and then you're ready to eat. That is as good as infrastructure service, where you have certain responsibilities and the provider also has certain responsibilities. On the other side, you can say, hey, I don't even have that much time. I don't want to go out and start buying those things because there are better things I want to do. So you will get the pizza delivered. You call your favorite pizza guy. That way you're not even responsible for anything that you see in green. Cheese, toppings, pizza dough, ovens, electricity. That's not your responsibility. Only thing you're responsible for is a place to sit and eat. That's all. And the last one is where you go drive out and pick your own pizza. You're not even responsible for the dining table. That's as good as software as service. Now you convert each of these blue and green things into something technical, where you'll see that everything in blue, which is networking, storage, servers, you're responsible end to end in each of those layers in on-premise infrastructure. That takes a lot of time, a lot of capital expenditure. Month on month, week on week, you will have recurring operational expenses as well. On the other side, infrastructure service, they have lesser responsibilities. But then, what's behind the scenes? What kind of cables are they using? Amazon Web Services, are they using straight cables, cross cables, or fiber optics? Storage, when I want to host something in the cloud, are they using NAS, network attached storage, SAN, storage area network, or DAS, direct attached storage? What kind of servers are being running in the background? Are they using Dell servers, IBM, HP, Lenovo, or did they make their own? Virtualization, are they using VMware, Hyper-V, Citrix Zen server? What are they using? These are certain things that we don't have to worry about. It's not our responsibility. Your responsibility starts from the moment you build your operating system. Choosing the right operating system for the application is your responsibility. Installing the antivirus on the operating system is your responsibility. Updating the definitions of the antivirus is your responsibility. Patching the server on time and rebooting it if required is your responsibility. Choosing the right kind of hard disk, SSD or HDD or magnetic, and selecting the right IOPS for the disk is your responsibility. What kind of applications can sit and are compatible with the OS is your responsibility. Amazon will have no hand on that. But the backend, everything that you see in green, is not your responsibility in infrastructure as service. In platform as service, your responsibilities are much lower. Your risk is also much lesser because the number of layers that you're handling and you're responsible for also reduces. Whenever you think of platform as service, think of database. Well, you build your database. The data in the database is your responsibility. If the data gets hacked, it's your responsibility. What kind of applications are connecting to my database? That's your responsibility. What's in the backend? like operating systems, IOPS, virtualization, network, storage, services, not your responsibility at all. In software as a service, there is no responsibility at all. For example, Gmail or Yahoo or Office 365. You don't have to care about nothing in that list. We know about public, private, and hybrid. We'll take a look at that demo in a minute. Well, these are 5 key characteristics of cloud computing. 5 key characteristics of cloud computing: moving clockwise, on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. Well, these are 5 key characteristics of cloud computing, and every cloud provider must have these key traits or key characteristics. Let's go over them one by one, moving clockwise, starting with the first one, on-demand self-service. As the word itself says, so as the string itself says, that it must be on demand. It must be on your demand, not on the cloud provider's demand. Cloud provider like Amazon or Microsoft, they cannot shut down their shops at 10 o'clock in the evening and then open up at 5 o'clock in the morning. They cannot do that. They must be available 24/7. That means you as a customer should be able to create, provision, deprovision resources whenever you want it, but not at the will of the cloud provider. That is on-demand self-service. Rapid elasticity. This is the most attractive feature of any cloud provider. And it works great in Amazon, it works great in Azure, also in AWS. This is one of the best features in cloud. Well, what does that mean? Let's understand this by using a example or a use case. The white box in the picture that you see, let's imagine that's load balancer, behind which you have 5 web servers. You got web server 1, 2, 3, 4, 5, right? You got 5 web servers. The traffic comes and hits the load balancer, and the job of the load balancer is to distribute the load between each of the web servers, right? Web server 1, 2, 3, 4, 5. Good. And let's say that's an e-commerce website, your favorite website from where you purchase your shirts, shoes, or anything that you may need, electronics. That is a website called www.myproducts.com. Great. Now myproducts.com says that it's a new year and Christmas time. Let's give our customers 60% discount. Anybody who shops between 6 o'clock to 8 o'clock, you'll get 60% discount. Anybody who shops from 8 o'clock to 10 o'clock, you'll get 80% discount. Great. And everybody who loves their tax paid money will go and hit that load balancer by going to www.myproducts.com and get traffic that lands up in one of those places. But remember, it's just not you and me who's accessing. It's just not you and me who wants to save money. It's the entire world, right? It's everybody. When they try to hit the load balancer, the traffic spikes up. The CPU goes about 70%. The network IOPS goes about 20,000. And the disk also starts spinning at its peak, like about 18,000 RPM. When that happens, there's a choke on the network. And when that happens, the web servers that are behind the load balancer, they will not be able to serve their customers appropriately, right? Because there's just 5 servers. Denial of service happens. The web service or web servers start to deny. They will start to deny the services to the customers because the CPU is overutilized. Networks is also overutilized. Cloud computing providers will let you increase the number of servers behind the load balancers automatically based on the load. So we can set up this system in such a way that when the CPU goes above 70%, create 1 more machine. So instead of 5 machines handling the load, now you have 6. If the CPU goes above 80%, create 2 more machines. Now instead of 5 machines, you have
8 machines handling the load. When the sale is over, the CPU goes below 30%, kill those machines, right? So you'll be back to the original pool size, which is 5. That is rapid elasticity based on demand. This is also called as horizontal scaling. So horizontal scaling is when new resources are automatically provisioned based on load and also deprovisioned based on lesser load. When you have this term horizontal scaling, you also have vertical scaling. The vertical scaling is when you increase the RAM from 4 GB to 8 GB, increase the number of CPUs from 2 to 4, and then power on the machine. That is vertical scaling. Do you have any questions so far?
Not from my side, Anand. Thank you.
That was the difference between vertical scaling and horizontal scaling and explanation about rapid elasticity. Let's move on to the next one. It's called as measured service. This is the third characteristic of cloud computing. Measured service, the device that you see is called as vernier calipers. You might have used that in your college days to measure the radius and diameter of anything. Yeah. We don't use this just for fun. We don't use it in the cloud at all. Yeah. So what it means is that anything that you build in the cloud, any infrastructure that is built in the cloud must be measured. Anything that you build in the cloud must be measured. There must not be any hidden costs. So to add on to this point, Amazon has got data centers everywhere. It's got about 14 data centers now. A couple of them in the East Coast, few of them in the West Coast. There's one in Sao Paulo, Brazil. There are 3 of them in the European Union region. There's one in India. There's a couple of them in the Southeast Asia, and the 2 of them in Australia. In total, we've got 14. So if you build infrastructure, let's say you build one server in East Coast with X configuration that has 1 CPU and 1 GB RAM. And then you build the exact same server in the European Union region or in a different region, exact same with 1 CPU and 1 GB RAM. And you run it for exact same amount of time, like 2 hours, right? The bills for both of these servers will be same? No, they will be different. That means that infrastructure provisioned with the same configuration running for the same amount of time in different data centers, the cost will be different because of several reasons, like because taxes are different, human labor costs are different, internet bills are different, electricity costs are different, real estate costs are different, right? That's why bills will be different. Resource pooling. Anything that you build in the cloud will be pooled between the customers. That means if you look at this picture that I was drawing in MS Paint, this one, this web server, let's say, belongs to business unit called A. And this database server, or this, let's say, this is also a web server. This belongs to a business unit called B, right? Regardless of whom they belong to, they are sitting on the same hypervisor. That means A and B, business units A and B, using the web server W1 and W2, they are consuming the resources from the same hardware. That means they are pooling the resources. That means they are sharing the resources. This kind of system is also called as multi-tenancy. This kind of system is called as multi-tenancy, where the resources are shared between different customers, right? So cloud provider must give us this option. On the other hand, if the cloud provider wants a physical hardware, he does not want his resources to sit next to another resource owned by a different customer. He wants a physical machine in the cloud. The cloud provider gives you that, right? It's just like your cab services. You want a full cab, your own cab, well, you get it. Or you want to share the cab with multiple people, well, you get that as well. But your bills will change when you share the cab with multiple people. You pool the cab with multiple people. You share the resources with multiple people. Your bills will be proportionately down. You want your own cab, yeah. You want to get your own limousine, well, you can get your own limousine, but then your bill will be higher, right? That's what it means. You want to get your own dedicated physical box, well, get it, but your bills will be higher. That's what it means. Okay. As a broad network access, this is the last feature. It says that, hey, you should be able to access from anywhere at any time. Internet is the backbone. You need to have a device that has internet. That's all. These boxes that you see are from a company called Gartner. Gartner is a well-known company that just does surveys, just like Forrester. Forrester is another company that does surveys, and on the left-hand side is a 2014 chart, and on the right-hand side is a 2016 chart. Gartner placed several cloud providers based on their market share in 2014 in various boxes. These boxes are represented as moving anti-clockwise. The first one on the top left-hand side is challengers, niche players, visionaries, and leaders quadrant. In 2014, Microsoft and Amazon Web Services were there in the leaders quadrant. That means they were doing great and adoption rate was very high in 2014. And in 2016, well, figures changed, a lot of bubbles bursted, companies do not exist now. For example, GoGrid isn't here, Dimension Data isn't here. They were either absorbed, acquired by other companies, or just had to evaporate. But the main difference here is Google changed its position from this point to this point. Microsoft has moved up the ladder. You see, there's a difference here, and has come close to Amazon Web Services. That's quite a lot of innovation that Microsoft has done to get this position in the leaders quadrant. Amazon has also moved up a little bit. In 2017, last year, Amazon has done a lot of things. There were downtimes, there were new services. So I'm really looking for the 2018 chart from Gartner to see where the positions of these companies will be. That's a political world outline map, right? That tells us where the data centers are located. You got 3 of them in the East Coast, or 3 of them in the West Coast, 2 of them in the East. There's 1 in Sao Paulo, Brazil, a couple of them here, etc. But then you might have noticed this already. There's a number inside this. There's a number inside this. 3, 5, 3. What does that mean? So here, if you see Sao Paulo, Brazil is a region. Within this region, you have availability zones. Availability zone are called as AZs, AZ or AZs. Availability zone. So every region has availability zone. North Virginia has, as per the picture, 5, but then in reality it has 6 availability zones, right? Ohio has 2, Oregon has 3, so North California has 3. So every region has availability zone, but what is it? Well, availability zone means that within one region you have separate data centers which are geographically apart. Let's draw a picture. Now this is your region. This is your North Virginia region. Within North Virginia, Amazon has 5 availability set: AZ1, AZ2, AZ3, AZ4, and AZ5. These are in 5 different regions within North Virginia, geographically distinct. So just in case something happens, to this AZ, you will have your data available in other AZs. These AZs, availability zones, are connected with low latency links. That means they are connected with fiber optics, right? Replication is happening between regions. So there is a built-in geographical redundancy. Your data is always available. So every region has at least two availability zones. Availability zones are connected to each other and are geographically at least 100 miles away from each other within that region. Okay, I hope that's clear. Right. Any questions you have? Well, this picture, this is the data center chart for Microsoft Azure. This is for Microsoft Azure. Microsoft has got more data centers than Amazon, right? They got a lot of these. This is for Microsoft Azure, and this is for Amazon Web Services. With that, we conclude the session. 1.5 hours time, and I'll leave rest of the time for questions, discussions, anything that you may want to ask. Tomorrow, we'll go ahead and learn how to create an Amazon account. Well, let me tell you right now. All you have to do is open up the browser and then just go here, aws.amazon.com/free. You will need a credit card to create this account, right? They will be charging about $1. You say create a free account. And it's just like your email address. You may have, if you have shopped with Amazon, right? Just for your e-commerce shopping, you bought something in Amazon.com, then you can say sign into existing AWS account, right? Sign into existing AWS account, and then use that account. So your account that you use to shop will be valid for this as well, right? Once you've filled in those details, it will ask you for your credit card information. How much will they charge? They will charge nothing. Well, $1 is deducted from your account, and that also comes back to your account once the account verification is complete. You get that $1 back. What else, right? It may take about 24 hours to get activated. So before you sleep today, go ahead and create an account. So that way, by tomorrow, this time, you'll be ready to do the labs. Sometimes it takes 24 hours to activate. Sometimes it does not. So if your information is not correct, like your address or your or whatever information that you have filled in is incorrect, then it may not let you create an account. To make sure that everything that you're typing in those fields or the input fields is correct, right? Well, that's all. It's pretty easy. How to create an account? It's just like you create a Gmail account or a Yahoo account. That's how it is. That's how simple that is. It should not take more than 5 minutes to create that account ready. Make sure you have a credit card right next to you before you start creating it. But there may be a question, why do they need our credit card? Why can't they just let us create it for free? Well, that's because there are malicious people with unethical intent out there on the internet, and they can just write a small script and say, hey, create 20 accounts for me, and each of those accounts create 500 servers, right? So they don't want any robots managing the infrastructure. They don't want any robots or automation going on by malicious users. So that's why when you put your credit card, it means that you are a real human account and not a fake bot. When you create an Amazon account, you get your account for 12 months. That means technically you can do all the labs for 1 year, right? That's big. You can do the labs for 1 year. That's all, man. I'm done. Unless you have any questions, please let me know. I'm just opening the forum now. Got any questions? Shoot.
I just have a question about the time. We said what time does it start? Because of the time difference. So I'm trying to see what time exactly I won't be online.
Okay, okay. Um, are you in EST or CST or California zone, PST?
I don't even know, but I'm on your money. What time are we on?
EST. East.
EST. Okay. So EST.
All right, so you're in EST, so it's about 10 p.m. now. So
Yeah.
we will be starting at about 8:30, 8:30 p.m. Eastern time.
Okay. 8:30 p.m. Okay.
8:30 p.m. Eastern time. Is that okay?
Yeah, that's fine with me.
That's fine. Thank you.
Money, how about you?
That's
Annie, how?
that's that's fine. That's fine with me.
Yeah.
Cool. That will be the same time as we started today, right?
Okay. Yeah, that works.
That will be about the same time we started today.
I got a quick question for you though. In case if somebody miss a class, is there any way they can get access to the class they miss?
Yeah, so we're trying to record these sessions just in case we miss it. I'll hand over the recordings to you. You can listen to it whenever you want it. On the other side, if you need any help in the labs or something, you have my email address. I'm open. I'm always ready to extend my help and try to make it more of a knowledge transfer session than a training session. That's the whole objective.
Oh, okay, thank you.
Yeah, I think that's all with me. So I'll definitely meet you online tomorrow, and
Sure.
I'll shoot you an email too.
Okay.
Thank
Yeah,
you very
yeah,
much.
yeah. I got it. Yeah.
All right. Thank you, sir.
Thank you. Thanks for your time. Any other questions, Ramesh?
Anand, I do not have any, it was very informative. Thank you very much. So,
Wow. Thank you. Thanks, Ramesh. Kiran?
Anand, one more thing is see, I'm straight away confirming my candidature for this, and I'll also talk to Srini. So, just to let you know.
Much appreciated, man. Thank you so much. Thank you.
Yeah, yeah.
Uh,
The
okay.
only thing is a kind request. The slides that you have shared, could you share with us, or how is it? And I'm just curious.
I can share the PDF format with you. No problem.
Yeah, that should be great. That should be great, Anand.
Okay. Ramesh, yeah, no problem.
Thank you.
Sure. Okay. Well, thanks, Kiran. Yeah, anything is fine if you're texting, as long as the information is getting relayed to me. That's good. Great. So let's catch up tomorrow again. Please create your account. It should not take more than 5 minutes to create an account. That was will be rocking and rolling with the real things. I like to talk less and show you more, so it will be more of labs and hands-on. So that way you'll be seeing things and then doing your own labs. Okay, thanks guys, and you have well a great year ahead. Happy New Year, and you have a fun time. Take care. Bye.
Thank you, Anand. You too. You too. Bye bye.
Bye.
Very small. In this, right hand. Quickly put the door, waste it.